So, I thought it'd be fun to make my own smartwatch, but I wanted it to look a lot different than a typical Apple Watch. I had just finished this working prototype, so let's take a little review of the progress so far. First things first, I love to sketch, to jot my ideas down and brainstorm, and taking the problem from a more artistic perspective rather than an engineering perspective at first. So I started sketching references of old watches like those from Casio, those vintage portable radios and TVs, and CRT displays before landing upon the Apollo mission control room as my main inspiration. I knew I wanted something that felt more analog and away from the full digital displays of modern smartwatches, and I thought it was really cool if I could incorporate a bunch of those like little buttons and LEDs that is distinct from the screen itself. My final sketch was decided upon considering what I wanted the screen size to be and to have sufficient space for the components inside. Now that I put a lot of time into a detailed sketch, this made it significantly easier to translate into Fusion 360 without too much reiteration. I had roughly modeled out the breakout boards that I'll be using, such as the ESP32 and the LiPo battery, to see if everything will fit inside, and sent it right out to be printed out of PLA on my Ender 3, which I will touch up with paint later down the line. While that was printing, I got to test my components. So I wired up the OLED to the ESP32 on a breadboard, but an odd thing happened is that anytime I would give it any commands, it would only flash these weird patterns of dots and lines before going entirely black. Now of course, this was not intentional, so it was time to troubleshoot. I was aware it was a SPI controlled display, so I double checked the wiring to the Seed Studio ESP32 datasheet that I found online. I double checked the solder joints, manually sent over some simple SPI commands to see if the board itself isn't damaged. I probed it with the oscilloscope, and you can clearly see the 8-bit clock signal on top, and then the simple command that I gave with only the last bit being 1. In terms of hardware, nothing seemed out of the ordinary, so it must be a library issue. I went ahead and ordered a new board just in case because they are cheap and I did need a new one anyways. But after looking at online forums for similar issues, it seemed that this was a conflict in between using virtual SPI pins versus hardware SPI pins. I am still confused why the hardware SPI pins didn't work for this ESP32 board, and that might be an issue that I will tackle later down the line when it comes to PCB prototyping, when I actually care more about maximizing the clock speed. And also, before I realized I could configure the Adafruit library to use either virtual or hardware, I had already found and tried an alternative library called SEMU_SSD1331 that was based on the original Adafruit commands, such as the GFX library, and actually had a faster refresh rate, which was very useful for my case. So thankfully, I did not need to modify any libraries just yet. These images shown here are of the mission control room, which are going to be my main references in the prototype clock faces, especially those blue diagnostic screens. While the real monitors would be assigned their own subsystem to monitor, such as life support, my displays would probably just be flavor text. One quick wire up cleanup later and it's ready to code using the Adafruit GFX library. In the middle of OLED troubleshooting and trying to see if I can get new parts, I tried to quickly code up a display using the monochrome I2C display that I had laying around, since I knew those had worked for me before. There's this neat site that I found called Walkwe that simulated a monochrome screen which I tried using so I didn't have to flash it to the ESP32 every time, since mine was being a little finicky with the bootloader mode, and for some reason it didn't want to send code without having to hold down the button. Now, the screen looked beautiful. It was exactly the feel I wanted, with the random numbers and divisions, the crispness of seeing the individual pixels, so I used this code as reference as I transferred over to the OLED screen, making ever so slight adjustments for the different screen size and to see how color would look. I'd rather not be carrying an instant seizure device on the go, so I limited to only refresh every second. I slapped on that blue background and it was ready to go. For the second screen, I based it off the control room's back wall display that are created by these giant iodophore projectors, showing things like trajectory and maps. Unfortunately, I did not have a spacecraft to track, so the graph is only a static bitmap that I drew up and converted to a .h file compatible with the Adafruit GFX library. This screen only updates every minute to prevent the flickering effect. I also really like the slight drop shadow that helped the clock number be way more readable. A feature that I wanted to try but didn't actually go through to the current working prototype is an MPU 6050 gyroscope and accelerometer. I had an idea for some kind of gesture interaction or some way to interact with wrist rotation, and I had a few of these boards laying around in my collection. Of course, I ran into some complication. So, did you know that sometimes buying these cheap Amazon bundles packages fake MPU 6050 chips inside of them? I had only realized this after running an I2C scanner and found that one of 3 of my chips were being detected. This is apparently a common issue documented on forums, and honestly, my best recommendation is just to scrap this end-of-life chip anyways and invest in something higher quality such as a 9-axis MEMS chip. Nonetheless, I did code up a display to see the acceleration and gyroscope's curves, but never really had a use beyond testing. Now that all the component testing is out of the way, the next step is to finally prep all the parts and start soldering all together. So, enjoy the montage. While assembling the case, I did run into a puzzling issue that I soon came to learn was superglue off-gassing or blooming, where the vapor as it dries builds up inside the coin vibration motor that I had and prevent it from functioning properly. I went back and decided to use hot glue instead of get a special glue, since visual was not such a big concern for this prototype. So that's pretty much the project to date. There are some additional features that I coded in to make it slightly more practical in public, but the battery life unfortunately is only roughly 6 hours even with the screen turned off. I did not wire the buttons correctly so that I can use the ESP32's ability to go into deep sleep mode. I had tweaked the main blue screen a little bit to show battery voltage at the bottom right, but I did forget to recode the screen updating every second. Now it's just only every minute, which isn't really that big of a concern. Clicking one of these side buttons will bring it to a menu screen where you can adjust the clock offset, which is useful when the ESP32 loses power and thus resets the real-time clock. You can also switch in between the two screens and turn off the display. The LEDs at the very bottom were intended for tracking actual statuses like battery level, but for now they are just randomly flickering. There are so many features that I want to improve upon and incorporate, which having a custom PCB would definitely be helpful with. I also want to replace the OLED with a TFT display, as that it is nearly impossible to see under direct sunlight. The case as well has been beaten up over time, and reprinting a new shell design would be ideal, especially with how bulky it is with the LiPo and all the breakout boards. But all that will come at a later, higher production video, so please stay tuned y'all and hope you enjoyed.